Hello, dear students, welcome back. Am I audible and visible to all of you? Yes, please let me know in the comment box. Am I audible and visible? Hello, dear students, welcome back. Hello, beta. Yes, I'm audible, right? Mm-hmm. Okay, that's very great. I guess in our previous classes, now up to the 8th class, we had the discussion on electric charges and properties, methods of charging, the Coulomb's law, superposition principle. Then we had the discussion on vector notation of Coulomb's law. Then we had the numerical based on these concepts, right? And I guess after that we had the discussion on what? Okay, electric field, the SHM problems, equilibrium problems. Mm-hmm. Then we had the superposition of electric field also. Okay. Then we had the derivation for your both level. The electric field due to point charge, electric field due to a line of charge density lambda. Then different cases if we have the infinite sort of line or a semi-infinite length wire, right? So we had that kind of discussions. Now we are left with two discussions from this particular topic, that the electric field due to circular arc, then due to the ring on the axial position. Okay, then we can discuss furthermore. Hello, beta. Hello, 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 hello. So this particular this lecture is also very important, right? If we talk about your board's examination and for your complete examination as well. And yeah, yesterday we were having facing some sort of internet issues, nah? That's why I need to cancel the yesterday's class. So today we are continuing from the lecture 8 only. Okay. Okay, I guess now we need to continue. 1 second. Okay. Okay, I guess the screen is also visible to you now. It is visible. Yeah, now the screen is visible to you now. Okay, as I had just marked the tick on it now, the point charge and linear charge. Now let's talk about the circular arc one. These are some numericals that we had done in our previous class. In today's class, we will be dealing about okay special cases. Okay, now let us mark the heading as due to circular arc. Okay, so you can write now electric field intensity. Electric field intensity due to circular arc. Circular arc. Let us suppose we have any sort of arc. Now, if this is my arc, this one is my arc. Suppose, okay, I will take a small arc. If this is my arc, okay, I need to get the electric field intensity at the center. If we closely look now, the arc is a part of a circle. Now, the arc is a part of this particular circle. Okay. Now, but we are taking only this particular part, and we have to find the electric field intensity due to this particular line or arc at this center. And suppose if linear charge density is given to us lambda, and we know that lambda is equals to charge per unit length. We know now up to this particular point, we know it. Okay. If we want to do a derivation like this, no, beta, what we need to do? Look, just connect these two ends. if the angle between them is given to be alpha, suppose it is alpha, it is what? Alpha. What I can do now, I will just divide the whole thing. I will just divide it. Look, I will just divide it from the center. Okay, I'll divide it from the center. Look now, if I divide the arc into two parts, so these parts are symmetrical. Okay, these are very symmetrical to each other. If I take it as the origin, this is the origin, right? Let us say it is the origin. Suppose. So now, if whole angle is alpha, if my whole angle is alpha, now I have to go to this direction also and to this direction also. Look, this is anti-clockwise. This is anti-clockwise. I will take it as a positive angle. Okay. No, it is not anti-clockwise. It is clockwise. Take it as a positive. Now it is a clockwise. It is a clockwise. I will take it as a positive. Okay. And this is an anti-clockwise. I will take it as a negative. If whole angle is alpha, that means this particular angle will be alpha by 2. Okay. So look now, can I write the whole angle is here given by, it is plus alpha by 2. This one is minus alpha by 2. Okay. Half part this side, half part this side. Alpha by 2 minus alpha by 2. If you are theta, then theta by 2 minus theta by 2. There is no issue. Now look, if we have any numerical like this now, so how we need to proceed? Go towards this particular side and take an element. Take an element of, go here theta, take an element of d theta. Take a small element of d theta. It is a d theta element. I will just zoom it. One second. Let's zoom it. Second. So that you can just understand it very better way. Look. Okay. So I go here. बेटा जी कौन आ रहे होंगे है ना तो यहाँ पे sorry so we need to just cut an element of d theta from the angle of theta. Now look, this particular line, the length of it is r, radius. Look, this is my, this sort is my what? This is my arc length, right? This is my arc length. Arc length. And arc length is radius into angle d theta. So the length of it would be how much? Sir, r d theta. Okay. So look, we have taken a small element here. So due to the small element, the center will face what? A small electric field, dE. dE, no? Look, dE. If this angle is theta, so this would be also theta. One second. One second. Okay. If this one is theta, so this one will be also theta. Okay. If this is dE, so this would be dE cos theta. And this will be dE sin theta. dE. Pare Samir. Okay. Now look here. Let us cut a small. Now look. If these two, this one and this one, these are symmetrical to each other. So let us take a one more element now. Go theta here and take a small element of d theta now. Same, okay? Theta, take a small element of d theta. Look now. D theta. So as per this one, now this particular length, it will also just apply some sort of electric field here. Theta, this is theta, right? So this would be how much? Sir, this would be dE sin theta. dE, and this would be how much? dE cos theta. Look, these are symmetrical to each other. What will happen now, beta? What will happen now? You can see from this figure, dE sine theta and d sine theta both are equal but opposite. So they will cancel their effect. Now you can see here, now look, d cos theta and d cos theta. We need to add them. Two vectors in one direction, just add them, right? Clear? Ruchita, hello beta. Look now. So we need to get now. Look, at the end, my resultant would be d cos theta only. Every time when you are taking these element now, this element also, this element also, this element also these element now. So every time d sine theta will get cancelled out, and my final result would be d cos theta only. Then, so now we need to write now the its value at the end. Now, look 1 second. Look now. So can I write now? Can I write now my E net, electric field net at center, is it equals to integration of only d cos theta? Is it integration of only d cos theta? Okay, d cos theta. Now look, what is de? What is de? Okay, what is de? Sir, we know that d would be kq, but here we have dq by r. Na? It is radius square. But one thing that we know now, the lambda is equals to dq by length of it dl. We know it. Yes. But what is dl? It is arc length. So we can replace the dl with rd theta. So lambda came out to be dq divided by rd theta. Okay. So therefore I can write dq came out to be lambda rd theta. So here I can write k lambda r d theta whole divided by r square. 1 r cancel out. So my de came out to be k lambda d theta by r. K lambda d theta by r. Then, so now I need to put here value now d. So d I can write here, it will be k lambda by r. Then we have cos theta. Then I can write d theta. Now put the limits now. So we have two limits. Here we have theta by 2 and minus theta by 2, or pi by 2 or minus, no, there is no pi now. Yeah, we have alpha by 2. Okay, so what I can write here? So alpha by 2. So here I can write, yeah, from this one it is minus alpha by 2 to plus alpha by 2. Look, k constant, lambda constant, r constant. So the integration of cos theta will be sine theta only. The limits are alpha by 2, then minus alpha by 2. Then look, can I write here? It is k lambda by r. Then upper limit is sine alpha by 2 minus lower limit is sine minus alpha by 2. We know that sine minus theta is equals to minus sine theta. We know it. This expression we know it, no? Done. So I can write k lambda by r. Look here, I can write sine alpha by 2. Then I can write plus sine alpha by 2. So 1 sine plus 1 sine, it is 2 sine. Can I write here now? Is it E net at the center is equals to 2k lambda by r sine alpha by 2. So this expression you need to memorize, or you need to just mug up, right? So due to point charge, what is the electric field? Q by r square. Due to line charge, we have two components. One is a perpendicular, one is a parallel one. For perpendicular, it is k lambda by r sine theta 1 plus sine theta 2. For the parallel one, it is k lambda by r cos theta 2 minus cos theta 1. For the arc, it is 2k lambda by r sine alpha by 2. Okay. Ruchita, hello. हाँ बेटा, I'm good. So we have परे से सर एस ग्रेबर हम तो कमिट पढ़ियो. सुनो यह बकवास करना आवश्यक चोण कमिट पढ़ा. यह प्राश्विन है. So I'm not very. 1 second, I need to just check something, right? But I'm not clear, right? 1 second, 1 second, 1 second. Okay, now. So this was a derivational part. Okay, this was what? A derivational part of what? Circular arc. So you need to remember now, it is only value. So it is what, beta? 2k lambda by r sine alpha by 2. Sine alpha by 2. Now look. Suppose we have a question now. Suppose we have a question, and my question is like, find for a semicircular arc, and charges are given like this. I need to find at the center. So what is my expression? So my expression is 2k lambda by r sine alpha by 2. Look here. Just join these two terminals. You will find my angle is 180 degree, or it is what? Pi. So can I write here? It is 2k lambda by r. That is sine alpha is pi by 2. Sine pi. Therefore, my value is 2k lambda by r only. For a semicircular ring, it is what? 2k lambda by r only. Let me go back and 1 second. Okay, if we have, let us suppose, look, but the direction, now if you want to find the direction, so direction would be, look, it would be in this way only. Why? Because electric field is always away from the positive charge. It is my net electric field, direction of it. If we have a numerical, but with the sign negative on the surface, with the negative sign on the surface. So how we can do it? Look, so angle is given to be pi radian or 180 degree. Okay, so E is same. E would be 2k lambda by r, but the direction of electric field will be now here, right? It is opposite to that. Here, this would be my direction of my electric field. Okay, now let us take an example of a quadrant. Let us take the example of a quadrant. Okay, so we have a quadrant like this. Look, we have a quadrant like this. Okay, on the quadrant we have charge distribution like this. Okay, here, so the way E is equals to 2k lambda by r sine alpha by 2. So is this alpha? Yes, so alpha equals to 90 degree or pi by 2. Put the value here, I guess I will get 2k lambda by r. It would be sine pi by 4. Okay, and sine pi by 4, it is value is given to how much? Is it 1 by root 2? Yes, sir. So my E net will be equals to 2k lambda by r multiplied by 1 by root 2. And 2 divided by root 2 will be equals to root 2 only. So my answer will be root 2 times k lambda by r. This one is my answer. Okay. Now let's talk about a circle one. Let's talk about a circle one. Okay. Let's talk about the circle one. If we have a circle like this, circle. Now on the circle we have the charge distribution like this. If we have the charge distribution like this, okay, and due to this particular charge distribution, I need to find electric field at the center. So if you know the angle between, it would be 360 degree or 2 pi radian. So my answer would be E is equals to 2k lambda by r, and it is sine angle. Angle is how much? 2 pi by pi. Is it like this? Okay. So 2 pi by pi, not 2 pi by 2. It's 2 pi by 2. Okay. So E is equals to 2k lambda by r. It would be sine pi only, and sine pi is 0. So my E would be equals to 0. So the electric field at the center would be only 0. Okay. Now let's do one more numerical based on the different polarities of charge. Let us suppose we have something like this. Look, something like this. Okay. So in half of the portion, if it is half of the portion, I have charge minus. Look. And in half of the portion, I have charge positive. That means here we have plus lambda, here we have minus lambda. So I need to find out the net electric field intensity at its center. Okay. So what we can do now, I can break down the numerical into two equal parts. This one, separate one, and this one is separate one. I can do like this now. Look, due to this particular portion, we know what is the answer. We know it would be root 2 k lambda by r. So, but its direction would be like this. Look, this would be my due to E, due to negative. And my positive will be like this, E due to positive. Okay, this is 45 degree, and this will be how much? 45 degree. What is E negative? We got it now upside. It is under root 2 k lambda by r. Also this one, na, it is how much? Under root 2 k lambda by r. Now my net would be from this, no? This would be my E net. E net. So when two vectors are equal, so I can write E net is equals to 2E cos theta by 2. 2. What is E? E is root 2 times k lambda by r. Cos angle is 90 degrees, so I can write cos 90 degree by 2. Is it 2 root 2 k lambda by r? Then we have cos 45. Can write 2 root 2 k lambda by r. Cos 45 is 1 by root 2. Root 2 cancel out. So what happens to my system now? There is an issue. 1 second. Okay. I can write my E net is equals to 2k lambda by r. This one is my final answer. This one is my final answer. 2k lambda by r. Clear? Easy, no? Easy? Okay. Let us do some PYQs, okay? Some important PYQs. Let us do some important and good PYQs. And my PYQs will be like, once again, okay. Look, we have a PYQ, okay? The PYQ will be like, look. If we have some structure like this is my question. Find electric field. Find electric field at center. Find electric field at center due to remaining due to remaining power. That simply indicates if we have something like this and my charge distribution is like this. Look. And my charge distribution on this ring or on this particular circle is given me like this. Let us divide it into 4 quadrants. Let us divide it into 4 quadrants. Okay. Now labeling it. This one is A side. This is B. This one is C. This one is D. This one is D. We will cut the portion. Okay. Let us cut this portion. If it is AKB, that's what it is AKB. Okay, this AKB, this portion. Let us cut AKB portion. Okay. Let us cut the AKB portion. Then we have to find out what will be the net electric field at the center due to the remaining portion, that is ADCB. Clear? Okay, look, we know one thing, that if we have any circle like structure, so electric field at the center would be 0. We know this one and we have proved this also, right? And if we cut this particular portion AKB, due to this AKB, it is a quadrant. This one is a quadrant, and we know the quadrant electric field will be in this direction. Look, it would be in this way. This is electric field due to AKB. Why, sir? Because it is a quadrant, no? And look, if we want to cancel out the electric field of AKB, we need to have a same electric field in this way. So this would be E due to remaining. E due to remaining. If we want to net electric field here 0, that simply indicates my values AKB and E remaining would be the same, then only we will get E0 at the center. How we can get it now? Look, can I write? First of all, E center due to net, it will be 0. So can I divide it? Yes, I will divide it. Electric field due to AKB plus electric field due to remaining portion. Due to remaining part, it would be 0. Clear? So if we talk about the magnitude only, na, if it is a vector, na, if we talk about only magnitude, so I can write E due to remaining is equals to, let us suppose it is minus times E due to AKB. Okay. And what is AKB? Is it root 2k lambda by r? So my answer is how much? This is my answer. Simple. Simple, no? But direction is from 0 to k. It is from what? 0 to k. Simple. Easy. And this was a PYQ. This was a PYQ. Okay, if you have any doubt about this particular numerical, you can ask me. And I'm going a little bit slow now, okay? It will be the same, but the direction would be the opposite to each other, where direction is along OQ. It is remaining here, na? R means remaining. It is remaining here. Okay, let's take an example from HCV. SC Verma book. Let's take an example from that book also. A very good numerical for your NEET. So we have a circular loop. What we have? We have a circular loop. Done? And the circular loop contains charge Q. And the radius is given to be A. Radius is how much? A. Okay. Now, a small element, a small elementary part, small elementary part of length dl, of length dl is cut. Then calculate electric field. Then calculate electric field at the center of loop due to remaining part. So what we have here, we have a loop. Now look, my loop is like this. Now we have cut this loop, small portion we cut it from here. Now small portion we cut it, and the length of this cut, it is given to be how much? dl. So we will assume it now. What? Sir, it is very small. If it is a very small, so I will assume this as a point. I will assume dl as a point here. I will assume it is a point. Okay. And due to this point, what is electric field? Sir, it would be K charge. Let's suppose if charge is Q, I will write KQ divided by radius square. I can write like this now. Okay. Now we know that at the center, my electric field will be 0. At center, due to whole ring, it would be how much? 0. But we now divide the ring into two parts. One we have a small dl length, then one we have without the dl length. Now I can write here electric field intensity due to dl plus electric field intensity due to remaining is equal to 0. Now I need to find out due to remaining also only now. So I can write electric field due to remaining only. I guess its answer came out to be minus electric field due to dl. Okay, due to dl. Look now, how I will write it. Look, electric field due to dl would be like this now. E k then charge would be dq divided by r square. So lambda is equal to dq by dl. So my dq would be equal to lambda times dl. So I can write here k lambda dl by r square. So what I can write here, sir, it would be minus k. What do we have now? K lambda dl whole divided by r square. Can I write like this? Yes. Small length, no? But here what we don't have r now, we have a. What we have a? We have a square, right? But what I can do, Navida, I will just manipulate the whole scenario now. I can just manipulate it. Okay. Let's suppose if lambda is not given, what we can do now? If lambda is not given, if my lambda is not given, so I guess we have charge q. It is on the circumference only. So my charge q is on the whole circumference. What is the circumference of the circle? So it would be 2 pi a. So on the 1 unit, my charge would be equal to how much? Is it 2 pi a divided by q? No, sir. It would be q divided by 2 pi. How much? It would be q divided by 2 pi. So for a 1 unit, my charge is q divided by 2 pi. Now I don't have 1 unit, I have dl. Can I write dl equals to q divided by 2 pi a into dl? Yes, sir. So instead of dl, I can write this one also. instead of dl, I can write this one also. Then, so look, my value came out to be dl equals to q times 2 pi a dl. Then that means my length is dl. So in dl portion, my charge, that is dq. dq is how much? It would be dq dl divided by 2 pi a. So can I write now electric field due to remaining portion? Electric field due to remaining portion, it is minus k dq divided by a square, minus k dq, I can write q dl whole divided by 2 pi a, then we have a square. Look, I can just simplify it. It would be minus k, then we have q dl whole divided by 2 pi a cube. So this will be my one more answer. This is my one more answer. Simple. Okay. These are ways to manipulate the numerical based on the situation, based on the numericals options given to us. Clear? What is minus? Minus is nothing. It is a basically a way. So my E remaining would be opposite to the direction of E due to the small element. Due to the small element. Now we are done with this one. Now let us complete electric field due to a uniformly charged ring. Let us put the heading as due to uniformly charged ring, uniformly charged ring, but at axial point only, at axial point. Axial point means the point which will be on the axis only. कार्तिक बेटा, you can do one thing now. आप एक काम करें, जो मेरा यहाँ पे चैनल में है ना, वहां पे एक डिस्क्रिप्शन में मेरा एक टेलीग्राम का यूजर नेम होगा, ठीक है, और मेरा ग्रुप का यूजर नेम होगा, वहां पे जाइए, फिर उसके डिस्क्रिप्शन मेरा मेरा पर्सनल यूजर नेम होगा, वहां पे मुझे एक मैसेज भेजिएगा, मैं वहां पे कोई काउंसलिंग कर दूंगा, कोई इशू. Okay, look what we have, uniformly charged ring. So let's make a uniformly charged ring now. Let's make a uniformly charged ring like this. It is what? It is uniformly charged link. One second. Can take it here. Okay. Okay. Now, okay. So look, we have a charged ring. This is center of this charge. If the radius of the ring is r, let us draw a line from it is, what happens to it, one second. Let us draw a line from its center. Let us draw a line from its center. So this line is an axial line. Okay. Let us take up any point here. Any point here. This is my point P. So at this particular point P, I need to find out its electric field. Look, the ring is also a symmetrical object. No, it is a symmetrical parameter also. Okay. Let us suppose if the distance from the center, if the distance from the center towards my point P is, let's go x. Okay. To do the derivation now, we need to cut a small element here, small element. Let us cut a small element with length dl. Small element with length dl. Now this dl will, if it is positive charge on it, no, Suppose if my ring is carrying positive charge. If my ring is carrying positive charge. Look, due to this particular thing, due to this particular dl length, so it will apply a electric field here. So my electric field will be in this way. Yes, sir. This is my electric field, no? So this is the direction of my electric field. So we have taken small element. So due to small element, I will be having small electric field. Very small electric field. If this angle is my theta, I guess this one is also my theta. Okay. Whenever we have any vector between any axes, now we need to just simplify it to coordinates. So this is DE. So this would be how much? Sir, DE cos theta. And this one will be how much? Sir, DE sin theta. It is a symmetrical body. This one is how much? A symmetrical body. If it is a symmetrical body, so I will be taking a one more element here. One more element with same angle, same length DL. So look, it will also act like the same. It will also act like the same. Okay, theta. This is also how much? Theta. This will be theta. This will be how much? DE, same DE. So one more component, sir, it will be DE sin theta. One more component, sir, how much? DE cos theta. Look, it is a symmetrical body. So D sin theta and D sin theta will be cutted. So my net will be DE cos theta only. My net will be DE cos theta only. Only how much? DE cos theta. Done? Now look. So what is my angle? So if we want to measure the angle means from the point where we need to start and the end point. Look, if we are talking about the whole one, I guess it is 360 degree. If I am going from this particular side and I am coming back, so how much angle? So 360 degree, or it is 2 pi. That means I am starting from 0 and coming back to 0 point after 2 pi radian. After 2 pi radian. So can I write now? Can I write now my electric field net? I guess it would be equals to, sir, DE cos theta only, and my limits would be from 0 to 2 pi. Done? Now I need to find out DE now. Na? What is DE? What is DE? I need to find out DE. Sir, DE is equals to K DQ divided by distance. Look here, na. It is very easy. Look, if this side is my X, this side is my R, I guess this side would be my R square plus X square root by Pythagoras theorem. Easy. So I can write, sir, it would be R square plus X square root whole square. So I can put the value now. Okay. So can I put the value now? Yes, sir. I will write integration of 0 to 2 pi. I can write K dq whole divided by, look, square root cancel out. I can write R square plus X square. Then cos theta. If we have a triangle like this, look, a right angle triangle. This one is X. This one is my R. It is theta. This is how much? R square plus X square root. So what is my cos theta? B by H. What is B? X. What is, it would be R square plus X square root. Clear? Yes, sir. So it would be X divided by under root of R square plus X square. And look, K is constant. Yes, sir. Let's suppose X is also constant. Okay, sir. Whole divided by R square plus X square. Now what we have, look, whole power 1. Look, this means 1 by 2. So 1 plus 1 by 2 is 3 by 2. 3 by 2. Okay. Now dq is not constant. So I will integrate it from 0 to 2 pi. Okay. Look, the whole charge is, let's suppose, Q. The whole charge is given to be how much? Q. So if we want to integrate dq, I guess the integration of dq will give only my q. It will give me only q, no? Yes, sir. So how to write now? Look, I guess my e net will be equals to kx whole divided by r square plus x square 3 by 2. Then integration of it will be q only. So or you can write k qx whole divided by r square plus x square 3 by 2. This is electric field intensity on the axial point of a ring. Easy? Easy or tough? Very easy, no? But the class will be 90 minutes. 90 minutes class. That way it will end at 12 o'clock. Because we need to end the whole syllabus. Now, look, my goal is, I guess Hasna knows that. My goal is to complete the whole 12 syllabus of your board and your NEET, your complete exam in JEE, na, before September. I want to complete your whole syllabus before September. Then I will start the 11th. You know that your examination would be in the month of February, March, right? So I will end my 12th before September. Then in September, October, November, December, in these 4 months, I will be completing your 11th backlogs. Then what we have? We have Jan and Feb. In these 2 months, you will just cover up your boards all or no, the boards one. Then you can just sit in the board examination and give your exam, give your the kind of entrance examination. Then no backlog from your 11th and 12th. This is my whole scenario, right? That's why I'm just taking 90 minutes class every day. Okay, now look. So you will be getting a direct numerical now. If you can see the PYQs, so you will get a numerical. Okay, we have a ring. We have a ring. So at what particular point my electric field intensity due to ring will be maximum? You will get this numerical now from PYQs, right? That is, at what particular point at X, my electric field will be maximum. So let us derive this one now. Let us derive this one now. Okay. So how to derive it? Look, you can see from this particular figure now. Look, R is constant. Look, we have variables here. Look, we have variables here. Look better. K is constant. Okay, sir. Q is constant. Okay, sir. Then X is varying now. So we need to find out a value where my maximum force will exist. So what I will write here? I will write for maximum force. For maximum force. For maximum force, you need to revise the concept of maximum minima from your 11th. From your 11th. That means to get my maxima, I need to differentiate my electric field with respect to x. Then I will put it as 0. So I will get my value of maxima. Look, E net we know now. What is E net? Sir, my E net is equals to K Q X whole divided by R square plus X square then 3 by 2. Let us do a derivation of it. Let's derive it. No? Easy task. Okay, now. So I will write dE net divided by dx. I can use u by v rule. The derivation of u by v will be v square. I will take v common, differentiation of u with respect to x minus u differentiation of v with respect to x. Simple. So I can write, look, I can write q, k and q is constant. Now I will take k and q outside then. Then I can use differentiation part. It would be x divided by r square plus x square 3 by 2. Look, kq this side. Now I will write r square plus x square 3 by 2 differentiation of x with respect to x minus x differentiation of the whole chunk of equation thing whole divided by the denominator is r square plus x square 3 by 2 whole square. I can write like this now. Look, put it as a 0. We know we need to put it as 0. When we take this term here, it will become 0. And when I take this term here, it will become 0. Now rearrange my equation. What I will get? I will get beta r square plus x square. Then I have root 3 by 2. 3 by 2. Look, this term will become 1. It is how much? 1. Okay. So what I can write here? I can write here minus. Then x as it is x. Then differentiation of this one. It would be how much? X to power n. So it is differentiation is nx n minus 1. So what is n here? So I can write n is 3 by 2. It would be 3 by 2. Then whole one is r square plus x square 3 by 2 minus 1. Then internal differentiation of which one? R square plus x square equals to 0. Look, I can write r square plus x square then 3 by 2 minus 3. Look, 3x, no? 3x by 2. I can write r square plus x square. What is 3 by 2 minus 1? It would be 1 by 2 only. Differentiation of r square is 0. Differentiation of x square is 2x. It is how much? 2x equals to 0. 2 cancel out. I will take, I can write or like this now. It is 3x square. It is r square plus x square. 1 by 2 is equals to r square plus x square 3 by 2. So how much? 3 by 2. So can I write now? It is 3x square is equals to r square plus x square 3 by 2 whole divided by r square plus x square 1 by 2. I will take it upside. It will become negative. It will become negative. So it would be r square plus x square. It is 3 by 2 minus 1 by 2. Okay. So it will be 3x square equals to r square plus x square 3 by 2 minus 1 by 2 would be how much? 2 by 2. That is 1 only. So I can write 3x square equals to r square plus x square. So I can write 3x square minus x square equals to r square. Okay. So it will be 2x square equals to r square. So x square is equals to r square by 2. So x will be equals to under root of r square by x. The x it is 2, no? It is 2 here. It will be how much? 2. 2. Therefore, it will be plus minus r by root 2. So this is the value of my x. This one is the value of my x where my electric field will be maximum. Why is it positive or negative? Look. If this is my ring, this is my line. No? So here it is 0. This is my r. This is my x. This is plus x. This one is minus x. So I can go here. If this is my r by under root 2 plus, so here I can write it minus. Now it is minus r by root 2. Here we have maximum values. What? There we have maximum values. It is what? A maximum value at this particular point. So this is how we can do it. Okay. Let us see how to draw a graph for it. Let us do one more numerical, or it is a subtopic of this particular topic where we will find it is what? It is graph. How to trace the graph. Look. We will start from the center only. Okay. First point at center. We will start from the center. I guess at center my x would be 0. Yes, sir. So my electric field is how much? Sir, it is k qx whole divided by r square plus x square then 3 by 2. Is it like this? Yes. So if I place x 0, so my all will be 0. That means electric field at the center of the ring is 0. Okay, sir. Second point. Second is my near point. It would be my near point. Near point simply indicates if my x is very less than r, very near point. So I can write E is equals to KQX whole divided by R square plus X square, then how much? 3 by 2. So look, if I am writing this particular step now, so it simply indicates my R square plus H square will be approximately equals to R square only. So I can write it KQX whole divided by R square, then 3 by 2. So it would be KQX whole divided by RQ, which is directly proportional to the x. So first part, at the center it is 0. Near part, it is directly proportional to the x. Now third part, third point. If you go beyond it, beyond means if my x is more than r now, okay? Far point. Far point. Far point simply indicates if my x is more than r. So I can write x square r square plus x square approximately equals to x square only. So now E is equals to KQX whole divided by R square plus X square, then 3 by 2. So I can write it as KQX whole divided by X square 3 by 2. 2 to cancel out. I can write KQX divided by XQ. 1 cancel out. So I can write KQ by X square. So I can write it's proportional to how much? 1 by X square. Okay, so from this particular derivational thing, we can conclude that at the center my electric field is 0. So from center to the nearer point is my electric field varies directly proportional. If I go beyond a certain point, it will vary as a 1 by x square. So now make a graph for it. The whole thing was for the graph thing, right? Let us make a graph for it now. Look. This is graph. This electric field line. This is my x line. Okay, look. First of all, it will go at the center, it is 0. Then it varies straight. It varies straight up to a certain point, while it will reach a maximum height. Its value would be how much? X equals to r by root 2. Then it will decline. It is not 0, it will decline then. Hyperbola, no? It's not like this. Okay, like this. E is proportional to 1 by x square. In the same way, if you go beyond it, now it's a negative way. It will be x equals to minus r by root 2. It will go in this way. This is how my graph it looks like. This was the whole thing. This was the whole thing that we need to discuss to get this thing done. Easy? Easy or tough? Huh? I guess super easy, no, beta? I guess super easy. Let us find some more interesting numericals for your class. So by doing this one, we had concluded how many derivations. Look, we will check it out. And we have a lot of time now. We have half an hour left with us. So we will do a lot more than look. Okay. Yes. So look, this one complete. This one complete. This one complete. 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 Now we are left with these four. These four we will complete after Gauss's law. Super easy, no? So these are the numericals that will be in every exams. No? You will be getting these numericals. Easy, right? If you find any doubts, you will just let me know. Okay, super easy. Okay, now let us start a new next topic known as electric force. Very interesting one. Okay, now I will be going to start some different topic, but in this topic we will be going to discuss those numericals in which we have to apply some previous concepts. Okay, okay. 1 second, 1 second, and 1 second. Look, I will just give you one brief thing now. Look, basically, in the whole chapter, we have to find out electric field. We need to find electric field. We need to find electric field. So to get my electric field, we have two ways. We have two ways. One, we have Coulomb's law. One, we have Coulomb's law. One, we have Gauss's law. Okay. So in the whole chapter, we need to discuss only these two things: Coulomb's law and Gauss's law. Coulomb's law and Gauss's law. Only these two things we need to discuss. Okay. Coulomb's law and Gauss's law. So the Coulomb's law, we will be discussing electric field effect due to small dimensional things. Just like a point charge, it's very small. Just like a ring, small, arc small. So due to these small parameters, if we want to find electric field, so we can use these principles or law by Coulomb's law. Okay. But if we want to find electric field due to a huge objects like spherical shells, like infinite sheet, plate, so I need to use Gauss's law. For, okay, look, small objects. So I can use Gauss's law for small objects, for sorry, the Coulomb's law for small objects, and I can use Gauss's law for big objects. Okay, so we have completed the Coulomb's law part. Okay, now let us start one more topic known as electric force. Known as electric force. Do you know what is electric force? Know what is electric force? Look, beta, what is electric force? Look now. We have a charged particle. What we have? We have a charged particle. Okay. I guess this charged particle that we are having, it has some sort of field around it. This charged particle is having a field around it, and that particular field is known as electric field. Okay. So we have a charge around a charged particle. It has its own field known as electric field. And if in this electric field we put another charged particle, if in this electric field, if we put another charged particle, that charged particle will feel a force. So basically this electric field will exert force. This electric field will exert force on the second object in the electric field. This electric field is known as electric field, electric force. Force due to electric field known as electric force. Look now, if let's say we have a charged particle here, Q. This charged particle has its own field around it. Okay, it has its own field around it. Let's say it is its own field. Now, in this field, if we put one more charged particle plus Q, this plus Q will feel a force of repulsion. In this electric field, the force is known as what? Electric field. This force is known as what? Electric force. So this electric force is equals to the charge multiplied the electric field. This equation you need to remember. So electric force is equals to charge into electric field. Very simple. If we have charged particle, we have two types of charged particles. One is positive charged particle, second one is negative charged particle. And positive charged particles electric field will be the along the direction of this force. Sorry, the force will be along the direction of electric field. That means if this is my charged particle, its electric field will be always outwards. We know it, na? It will be always outwards. Okay. And if we place a charged particle positive here, positive here, positive here, so the positive will feel a force in the direction of electric field, in the direction of electric field. This is the example. If we have negative, it will feel opposite to the direction of electric field. Opposite to the direction of electric field. How, sir? Look, we know that electric field is outwards, but here if we have a negative charge, the positive will attract negative charge by force F. Look, this force F is opposite. The force F is opposite to the electric field. Very, very easy. It is very easy, no? Very easy. Look now. Look now. Look now. Look now. Suppose we have electric field. Suppose this is my electric field. Suppose these lines, straight lines represent my electric field. Suppose these are what? These are electric fields. And in this electric field, I place an object here. In this electric field, what? I place an object here. Look now, here I place an object. This is my object. And the charge of this object is plus Q. As per the upper definition, the plus Q, if it is at rest, if I just put it, look, that's about it is a river. River is going. I'm just putting some very light object in the river. I guess this small light object will flow in the direction of the river. The same way, this is my electric field. I just put a small charge here plus Q as a rest. Na? It will feel a force, and that force is directly in the direction of my electric field. Okay. If now I just place here a negative charge, suppose I just place here a negative charge, same condition rest, it will feel a force in the opposite direction of my electric field. Then, so my initial velocity is zero. Initial velocity is zero. So how to find my final velocity? Interesting partner. If look, let's suppose I have placed a particle inside a electric field. Now, initial it is velocity is zero. After spending time t, it is velocity is v. It is start moving. Now, how to find this velocity v? How to manipulate these things now? Look, let us put some kinematics here to get my velocity v value. Okay, I guess I can write here after t time. After t time, I can write v is equal to u plus at. U is zero. I guess my velocity is equal to a into t. Yes, sir. My velocity after t would be equal to at. But here, one thing is unknown, that is my acceleration. How to find the acceleration? Look now, simple, na? I guess my equation is F. F is equals to QE. We derive it like now, electric force. What is force according to the second law? Is it M into A? It will be Q into E. I can write my acceleration would be equals to QE by M. It is QE by M. I will place the value here now. So V is equals to QE by M multiplied by time t. This is my final value. This would be my final value, V. If somebody will ask you find kinetic energy, it will be 1 by 2 mv square. Okay, so you can put the value of V, na? You will get the kinetic energy also of your particle. Easy? I guess my network is good now. Let's check it out. That is good. Easy, better. If you have any confusion, you can just ask me. Hmm? Why then there is some sort of glitch? Am I lagging? No, no. No, my network is good. Any doubts? Clear? Okay. Look now. Let us do a numerical then. One numerical. Okay. And this numerical is from HCV. Do you know what is HCV? I guess you know now what is HCV. Okay. Look now. If we have an infinitely long wire, infinitely long, something like this, with density of plus lambda, and with r distance apart, r distance here, I have a particle, electron, and this electron is revolving. The electron is revolving around this. Okay, the electron is revolving around this rod. Electron is revolving around this rod. Find kinetic energy. Find kinetic energy of electron. Very easy and very simple. Okay. So how to think about the way by which I will get my answer? Look, if any object in the universe is doing a circular motion, okay, then there will be a centripetal force. So we have two equations for centripetal force: mv square by r or m omega square into r. Mv square r, m omega square r. M omega square r we can use where we need to find time period. If you want to find velocity, I will write mv square by r. Look here, look here. I guess this is rod positive. This is my electron. So my electric force will be like this, and my centripetal force will be like that. So my electric field like this, no? Centripetal force. So these will be balanced. So can I write Fc is equals to Fe? Yes, sir. What is Fe? It will be mv square by r. What is Fe? What is going to be Fe? Sir, it is Q times E. Q times E. Okay, no issue. So I can write mv square by r. Q is the E. It will be EE. So I guess V came out to be under root of EER by M. Clear? EER by M. Yes, sir. EER by M. Look now, look now. Do you know what is the electric field due to the rod? Yes, sir. Infinite rod. It will be 2k lambda by r. Apply the value. My velocity came out to be under root of E into 2k lambda by r into r whole divided by m. R cancel out. It would be equals to 2k lambda E by m. So what is my kinetic energy? Half mv square. It would be 1 by 2m into v square is 2k lambda E by m. M cancel out, E cancel out. So my kinetic energy of the electron revolving would be how much? K lambda times E. Or you can write 1 over 4 pi epsilon naught lambda times E. These are two options for my answer. Easy? Easy or super easy? Okay, so I need a couple of minutes so that I will just complete this topic. Then from tomorrow we will be discussing electric field lines. Okay, from tomorrow's class I will find what electric field lines. If you have any doubt now, you can let me know here. Very easy. Okay, one more numerical. Okay, one more numerical. Suppose numerical is if we have charged water droplet. If we have charged water drop, okay, I have to maintain one condition, that is this charged water drop should be equilibrium. That means it should be hanging in air, or I can write it should be suspended in air, right? Suspended in air. If we want the particle to be suspended in air, what things I need to apply? Look, if this is my particle with some charge on it, first of all, it has some charge q on it. Okay, charge q on it. So look, I guess this particle is having some mass also. Okay, if mass is there, so gravity is there, so mg is there. If I need to place the whole thing in the air, so there should be a force also. Yes sir, force, electric force, if it is positive. So that means my electric field should be in this way. Okay, so if this should be hanging now, so my condition would be equals to, sir, my mg should be equals to fe. This is my condition. Okay, so I can write mg. What is fe? It is q times e. Electric field which is which we need to get this particle suspended in air, it equals to mg by q. This is my answer. Easy, no? Done? It's very easy, no? It's very easy. Very, very easy. Very easy. Okay. Okay, we have a numerical, a good numerical. And numerical like we have proton and we have electron. Two particles, proton and electron, with different masses but same charge, opposite nature. Both are released. Both are released from rest. From rest. First thing, a ratio of force experienced by them. Second part, a ratio of acceleration. So these two things we need to find out. One is ratio of force experienced by the proton and electron, and ratio of acceleration. Look, I guess in proton and electron only one thing differs, that is charge. So if this charge is plus e, its charge would be minus e. Okay. So what is force? What is force now? I guess force is nothing. It would be q into e. Look, electric field is same. That means my force is proportional to the charge. Charge is same. So can I write, if it is same now? If charge is same, then for this particular thing, the force experienced by electron divided by force experienced by proton equals to 1 by 1. Because charge is same now, it is equals to 1. Now what about the ratio of acceleration? What about it? Look, force is same. Force is same now. Force experienced is same. So force is equals to mass into acceleration. Force is same. So can I write then acceleration is inversely proportional to the m? Yes, sir. And we know one thing, mass of proton is more than mass of electron. We know these things. Therefore, acceleration of proton divided by acceleration of electron is equals to mass of electron divided by mass of proton. Less than 1. Easy? Easy or tough? Amida? Super easy? Okay. Let us do a one last numerical. Okay. One last numerical. I guess we have 10 minutes now. Let us do one now last numerical. And we are doing some NEET PYQs. Okay. These are important. Same electron and proton. Electron and proton released in uniform electric field. Electric field. If same distance is covered in time T1 and T2, then find a ratio of T2 by T1. Okay, this numerical we need to discuss now. Okay, so what we have to find out, we need to, this basically this numerical is from I guess 2016 of NEET, na toughest paper for NEET. Okay, so look, what are the things given to us? Electron and proton. So these are released from rest. So I can write U equals to 0. It is released now. Equal to 0. Then same distance covered. So I guess S is same. S is distance and distance is same. So what I can write? What I can write? Equation is S equals to UT plus 1 half of AT square. This term is 0. Why? Because U is 0. This term is constant. Why? Same distance. Okay. So what I can write now? Look, 1 by 2 is also, what happens to it now? Look, 1 second. Blank. 1 second, 1 second, 1 second. One second, 1 second. Look now. Look, 1 by t is also constant, no? So what I can write now? Can I write here कि A is inversely proportional to t square, or t is proportional to the 1 divided by under root of accelerations? I can write like these two terms. I can write like these. Okay. Now to find out the time ratio, I need acceleration. Where, from which equation I will get it? Look, I guess F is equals to Q times E. F is m into A equals to Q times E. So acceleration is equals to QE by m. So acceleration of proton, electron. Proton is equals to Q. Q is same, so I can write E, no? E is same to E divided by, it is MP. It is E divided by MP. Now it is M, which one? ME, right? So look, from this particular figure, you can just look, E same, E same. So acceleration is inversely proportional to their masses. Done? acceleration is inversely proportional to the masses, then I can write T of T2 means proton. So T proton divided by T electron. That means T2 divided by T1 is equals to under root of A electron divided by under root of A proton, which is equals to under root of mass of proton divided by under root of mass of electron. We can write like this. Okay, this is the answer. This is my answer. This one is my answer. Easy? Easy now? Okay, then I will wait for 1-2 minutes. If you have any confusion or if you have any doubts, if you want to ask me anything, you are most welcome. I will be in the session for 2 minutes. So in tomorrow's class, we will be discussing electric field lines and Gauss's law. Okay, in tomorrow's session, we will be discussing electric field lines, electric flux and Gauss's law. These three topics we will try to complete in tomorrow's class. Study with Manjula. Beta, you can do one thing now. Go to this particular channel. You will find a Telegram link. There you will find my username. Just connect with me there. Okay, I will be counseling you. There is no issue. Okay. I guess we need to stop the class now. No, if you need some more numericals, we can discuss those things. No, if not. 1 second. 1 second. Okay. I guess this is all for today. No. If you have any doubt, you can just let me know. Okay. I don't think that you should have any doubts. No. Yeah, you can just, yeah, no issue. Send me the message, there is no issue. I am for you, no? Look, beta, what you need to just think about the branches, no? Look, you are getting civil in IIT Madras. You are getting from Kharagpur, Roorkee, Kanpur Chemical in IIT KGP, Hyderabad, etc., and the mechanical in same and electrical. Bhumeshwar, which is better to choose? Madras is good, Kharagpur is good, right? Civil in these two. Ping me message now, I will just guide you, no issue. Okay, I guess we are done with today's class. Tomorrow we will be discussing a lot of numericals based on electric field lines and more problems on pendulum and pendulum. Then we have SHM, more problems. Then we will start electric flux, then Gauss's law. Okay, every day now my schedule would be like every day what we can do now, beta. Okay, 1 second. Every day my class will be start at 10:30 p.m. up to 12 o'clock every day. Okay, every day, because our goal is to complete syllabus before September. Before September, we need to finish the whole syllabus. Yes, in Telegram channel na, you will go to the description part. You will find my username there. Na, just ping me a message. Before September, we want to complete our whole syllabus of 12th physics. Okay. Then from September to December, we will complete 11th backlogs. That means starting from 11th now. So you will be ready to go for your examinations. Okay. I guess we need to stop now. Thank you, beta. Thank you very much for the session, to be the session. Okay. If you have, okay, there is no doubts, then you have me, I ask it for that thing. Thank you, beta. Good night. Thank you. Bye. Okay. Bye, beta.